Welcome back. At this point, we've disassembled this machine into its two primary electronic components, the playfield circuit board and the backbox circuit board. We've traced out all of the circuitry on the playfield and figured out what each of the pins on this microcontroller does within the circuit. Also traced out the circuitry on the backbox board to figure out what this slave microcontroller here does. And reverse engineered the protocol between the playfield board and the backbox board to learn how to control the score digits and the lights within the backbox, and emulated that protocol, that SPI protocol, using some custom written code on a Teensy microcontroller, which allows us to control the score digits and the LEDs in the backbox. So at this point, I think we're ready to remove this microcontroller on the playfield board and wire in a Teensy to each of these pins to control the playfield LEDs and to read in the hardware switches on the playfield and these optical switches. I think we're pretty close, once we get to that point, to being able to control the playfield and control the backbox, tie them all together, and start making our own rules and gameplay using a custom microcontroller. Let's get into it. Honestly, I've been kind of dreading this because I'm not sure how it's going to work. I'm not sure if I'm going to be able to get this microcontroller off the board because of how it's soldered on there. So I'm used to like through-hole components where I can use a solder sucker to desolder the components, but these are castellated vias. The board is just kind of laid on top of the playfield board, and then there are vias, holes in the board, that are sliced in half, so you've got little semicircles on each of these pins. And the solder is just kind of laid from the micro down to the playfield board. And I'm not really sure how to desolder that. I bought this Hacko desoldering tool to use with through-hole components because it works a whole lot better than a solder sucker. And I'm hoping maybe I can suck enough solder off these castellated vias where I can remove the microcontroller. Then I'm kind of worried that maybe it's glued to the playfield board, and if that's the case, I don't know how I'm going to get that off. And I really can't get my own micro into this system without removing this one. So it's got to come off, or it kind of puts a stop on this whole project. So, and you know, I almost bought a hot air rework station that she would use for surface mount components, because that kind of seems like the way I should go, but I don't have one. So I'm going to try to use this desoldering tool to pull the solder off of these castellated vias and see if I can get this micro off the board. So I'm going to start with some flux, and I'm going to just kind of brush some of this flux just a little bit on each of these vias. Shouldn't take much. And then just see if I can suck this solder off. Well, that came out pretty well. I wish I had a magnifying glass and see. Yeah, I guess I'll go down the line. That came off pretty well. I'll go down the line with each of these. I'm gonna be careful if this thing is hot. Well, it did a pretty good job of getting the solder off, but I gotta say, this thing is still pretty solidly on there. It's not moving at all. So I think I'm gonna have to maybe invest in a hot air rework station to try to heat all these solder joints up at once and see if I can pluck it off with some tweezers. This is what I was afraid of. Well, I take it back. So I was reviewing the camera footage and I saw that this side, it looked like I desoldered it pretty well. This side, these top pins, or these top vias, still had a good amount of solder on them, and I did a pretty good job desoldering these right here, and then this bottom one wasn't hardly desoldered at all. So I thought, well, maybe it's just stuck because I only desoldered half the pins on this side. And I started just prying at it with my fingernail, and I was able to raise up this side of the board. So it looks like maybe I just need to desolder these better. I'm just gonna hit this with some more flux and on the right side there. Let's see if we can get this board to come off. At this point, I probably could just rip it off, but I don't want to, take a chance of. I think these were already desoldered pretty well. Take a chance of pulling these pads off or something.
let's see. It's hard for me to see what's going on. It's hot. And that's certainly easier. Stuck on something. There it goes. Hey, hey. Look at that.
Well, unfortunately, it looks like I did rip a couple pads off. I don't know if you can see it well here, but right where my fingernail is, you can see a little pad hanging off. And the other one, right where my nail is, right there. Let's get a little better picture of the damage here. Yeah, so you can see that pad there. I ripped that one off pretty good. There's a little bit of metal left on the left side there. And actually the ones on the right don't look bad at all. Which was it? Let's put this micro back on here real quick. So it was that one there, and that actually looks fine. And then on the left side, yeah, you can see I ripped that pad off right there. The two pins where I pulled the pads up are pin 7 and 22. So that's this one here and this one here. 7 and 22. So 7 the motor enable and 22 the chute. So
22 here, this light purple lavender line going to the opto and the ball chute, and pin 7 here, which is the motor, the enable pin for the motor and the pops. So I'll have to take a look at those and see if there's any connectivity between the pad and the next component. So I should trace pin 7 to, which resistor is that? R43, and I should trace pin 22 to R28. Alright, let's see. Alright, let's see if we can measure this here. Well, there's still something. Looks like the back of the pad, or the inside of the pad has something. That's good. Looks like there's still something there too. That might be good. Just have to flow a little bit of solder on there, which I'll have to anyway when I wire, or when I connect wires to these pads. So hopefully it all works out. I'll do a continuity check after I get wires soldered to these pads and get it broken out to a breadboard. Up until this point, my goal has been to drive the backbox using my microcontroller without going through this playfield board. But now that I've got the micro off of this board, it's time to integrate my microcontroller into this playfield circuitry so that I can drive the backbox through this ribbon cable. So I've been thinking about how to do that. I think I'm going to solder some thin wire to these pads here on the playfield board, and then run them to my breadboard where I have my microcontroller. Just to keep things simple at first, I only want to solder the wires that I need, or the pads that I need. So I was looking back through my diagrams to see which pads I need to wire, and I realized that I never really figured out how the power circuitry here works. So we've got ground coming in on pin 10 and regulated power coming in on pin 9, but I never figured out what pin 8 did. I'm kind of afraid if I just wire up 9 and 10 that the circuit's not going to work without pin 8 being present. I can't really tell what these components are and what they do. So I think before I connect the microcontroller, I might go ahead and connect power to the board here and do some measurements on these power and ground pins and whatever this yellow connection is here, and see if I can figure out the behavior of whatever that is on pin 8. I think I'm going to do that by reintroducing the battery compartment. So I'll wire up my power supply here to the battery terminals, and then drive the playfield through the power connector here. And then take some measurements on these 3 power related pins and see what I can figure out. Okay, so I've got my playfield board hooked up to the battery compartment, and I've got a power supply hooked up to the positive and negative leads on the battery connectors, running 4.5 volts as you would get from 3 C-cell batteries. So let's check the power pins. 1, 2, 3, 4, 5, 6. And the next one up is VCC, and I forgot to turn it on. Turn on the battery compartment. 1, 2, 3, 4, 5, 6. This one is VCC, and we've got 3.5 volts. Nice. Let's see what we've got on that mystery connection. Nothing. Nothing at all. Well, that's good news. So even without that mystery connection, I'm still getting 3.5 volts at VCC. So maybe for now, I'll just not wire that pin, and maybe I'll just see what happens later. My fear was that this micro was doing something on that pin to make power appear. And that doesn't make a whole lot of sense because you couldn't get power to the micro to do anything on that pin. But anyway, now that I know I'm getting solid power on that pad, I'll just wire it to that. Alright, so I need to connect wires to the power and SPI connections. So, looking at the 6th and 7th pins up, 1, 2, 3, 4, 5, 6, 7, for power, and SPI I need the 2nd, 3rd, and 4th pads down on the right. So I think I'll just drop some solder beads on these pads, and then I'll come back and solder on the wires. Alright, so I'm looking at the 6th and 7th pins up on the left side. And 3 pins up here. Just put a little flux on these connections. Because I'm going to have to solder them again to put the wires on. There's not a whole lot on there to grab onto. Okay, there's power. Get these 3 SPI connections. And then these connections are not good. I'm gonna have to figure out a different way of doing this. That's all over the place. Jeez. Ew, that's already a broken joint there. Alright. Power and ground and the 3 SPI pins.
So now that I've got power and SPI on the playfield board, if everything's gone right here, I should be able to connect these wires to the microcontroller on the breadboard and connect the backbox display board back to the ribbon cable on the playfield board, and connect my power supply to the battery terminals and be able to power the microcontroller from the battery compartment and drive the backbox display from the playfield board, with the playfield board being driven by the microcontroller on the breadboard. So I'll get that wired up and we'll see if everything's working. Alright, so I've got it wired up. I've got 4.5 volts running to the battery compartment, which is connected to the playfield. I've got the power and ground and the SPI pins connected to power and ground and the SPI pins on my micro. And the back box connected to the playfield as it would be in the actual machine. Good news and bad news. Good news is it works. So you can see the microcontroller is driving the LEDs in the display and the LEDs in the back box. Also, the LEDs that are controlled by the microcontroller in the back box are lit on the playfield. I'd like to turn this board over and see which ones are lit to make sure that the right ones are lit, that I wasn't missing anything when I did the analysis of the back box circuitry. But I'm afraid to touch it. And the reason why is because I ripped the center pad off, those 3 SPI pins. The middle one, the pad just completely lifted and started peeling back when I moved these wires to get them wired up to the micro. So it's really fragile right now, and I don't know exactly what to do. I've got a lot more pins I'm going to have to solder, a lot more pads I'm going to have to solder, and I'm afraid of lifting them. So I think what probably needs to be done is got to find some way of tacking that pad back down, or otherwise connecting the trace somewhere else. I'll have to trace it and see what component it goes to, and maybe I can wire in there. And I also have to figure out how to get some strain relief on these wires here. Maybe some hot glue. I've got them just twist tied to the board right now, and that's not doing a good job of relieving any tension, because when the wires twist, the twist goes all the way through the twist tie and hits that pad, which is what ripped it off before. So I have to find some way of stopping the wires from twisting. Otherwise, the rest of these pads are going to lift up, and then I'll be screwed. But good news. Everything seems to work that I expected to work. Now I might want to play with the protocol that's going over the SPI bus and see if I can get these LEDs to light. You can see LED P is lit. LED G is lit as well. Whereas M is not, for instance, and neither is E. So hopefully M and E are controlled directly by the micro, and P and G are controlled by the other controller in the back box. I'll have to take a look and see. I updated the code running on the microcontroller, and now I'm able to see that I can control
not only the backbox LEDs, but also several of the playfield LEDs. So those are all the lights that are controlled by the backbox. So it seems to be working pretty well. See if we can get a close-up of that failed pad that I broke. Yeah, so that middle pad is lifted off there. And actually, I think maybe the pad in front of it, the bottom pad, is starting to lift off too. I'm thinking maybe I'm gonna have to design a little circuit board that can fit where the old one did, with castellated vias on the sides like the original microcontroller had, and then maybe put some through holes on that I can poke these wires into and solder them on the top. The problem is I can't solder any through hole headers on because they can't poke through the bottom of the micro because the micro has to sit flush with this board so that I can solder onto these pads. I don't know, so I'm kind of thinking I'm gonna have to desolder these wires off of here now that I know that it works, and switch gears and start designing a board that I can mount on here. I desoldered the wires from the pads, and you can see the carnage left on the, especially on the SPI pins. Yep, I'm not going to do that again. I think I'll move forward with the designing a little daughter board to with some castellated vias to kind of surface mount to these pads. I think the next step is for me to design my own small circuit board to mount in place of this original board, because soldering these wires directly to the pads didn't work out, and I'm afraid if I do that anymore I'm going to cause irreparable damage to these pads. So I think I'm going to start designing my own board with castellated vias on the side, just like this one has, so I can mount to the same footprint. And then maybe, I don't know, I'll look at some different options for connectors that I can mount to the board. The problem is, I normally like to work with through-hole components, but since this mounts flush to this board, there's no room to solder anything on the bottom of whatever board I design. So whatever I come up with, I'll have to be able to solder from the top, and it has to be sturdy enough to hold some wires pretty tightly and fit underneath this board, because I believe when it's mounted in the chassis that this sits on top like so, and I don't know how much clearance there is between this and the bottom of the battery compartment. So whatever solution I come up with for wire connectors, can't have any protrusion at the bottom of the board. It can't be too tall. It's got to hold somewhere around 30 different wires on this small space. Because I can't think of a way to directly mount my microcontroller on top of a small board like this. So I think I'm going to have to locate my micro somewhere else. There's a little bit of room underneath the
speaker here, for instance, I could stow it there, but I'm gonna have to run some kind of wiring from the board I create here on the footprint of the old microcontroller to my micro, wherever I put it. And I bet there's about 30 pins I'm gonna have to wire to get from here to there. So I've got some designing to do, some thinking to do. So I'll proceed down that path, and I'll see you later.